Greetings, everyone. This is Brian Chamberlain, and I'm here to assist in educating you on how to use the ASCE7 calculator. The first thing to note is where to find that. For most of you, it will be on your dashboard, which is password protected. So once you get there, you get your password. And then under Tools, we basically scroll down until you find the ASCE7 calculator. We click on the ASCE7 calculator. And you'll notice that there's a pull down and that there's actually three versions at this point. We have the ASCE 705, which is rarely used, the ASCE 710, which is used by a small portion still of the United States, and the ASCE 716, which is over 50% of the United States is actually using that. So we're going to be using the 716 as our main example. The others are very similar in its application, so that should not be an issue about translating the training from this to the other calculators. The document is actually based upon a minimum slope of 1.5 inches or less. Anything greater than that, a different method would have to be used, so keep that in mind. Then this is also based upon other parameters of a flat roof, specifically enclosed type structures. And this also is not associated to the factory mutual other than possibly relating it to their uplift pressures. So you cannot use this calculator to verify FM uplift pressures. You have to actually go to the roof nav calculators and use that device, not this one. There are two different measurements. We're going to focus on the English version. There are going to be always these three tabs down here where you can actually back up if necessary, go start from the beginning, or just continue. And so we're going to continue at this point. At this location, this is where we basically add the information of who you are. This helps fill out the document at the end to make sure that you have all the correct information that would be necessary to offer for a customer. This way they have your address, your phone number, your email, and your location associated to your business. There we go. I believe in some cases this may already pre-populate, which would be great, but I went through the hard way at this point. Then this comes into the heart of it, where we're looking at the project name, be as whatever you wish to use. I'm just going to use the Carlisle and Pennsylvania in this example, but you can actually put the location of the project for this, so you can actually have those for the customer. You use the length of the building and then a width, keeping in mind that the width is always going to be the lesser of the two dimensions. That gives you an idea how much square footage. And in some of the calculators, not this one specifically, use those dimensions to determine the additional perimeter zone that we'll be discussing in a little bit. Then we go into the deck type. This particular doc portion is not going to be required for the calculations. It is necessary if you submit this document to us, and then we can actually assist you a little bit better and we can fine tune if there's some questions. And then of course there's the membrane. That always looks good on a nice piece of paper for the customer. This is where the parameters become very important on the building itself. How high is it? Obviously, the higher you get, the more the wind will actually affect the building. So we need to know specifically that. The calculator is based upon 10 foot, as you saw. So you cannot round in 45 feet or anything like that. So always go to the greater height, never round down, round up. Then there's the exposure category. This involves the surrounding terrain. And a way to find that out is actually tapping on this link, and it gives you a definition of those exposures. Exposure B is basically an urban, suburban type of area. Exposure C is an open type of terrain. And then D is basically a large body of water, salt flats, or those kind of areas within 1 mile. So it's just open, so the wind just blows as hard as possible. This portion about the wind speed coefficient associated to escarpments is a bit more complicated, but I would basically leave that as a 1 that's allowed by the ASCE7. That's a conservative approach and just makes it a little bit easier. The wind directionality factor is associated to the fact that wind is not constantly straight. It does fluctuate and move around. So they have this factor associated to it, and it's acceptable within the building code to use that. In the ASCE 716, not in the previous ones, they do allow an elevation factor. So you can actually find out what your local elevation versus the height sea level wise and be able to determine that. Now I'll show you some tools that can help you determine that in just a minute. Then there's the use of the building. That's where the categories come in, or risk categories come in. And in this case, there's the definitions of those risk categories, giving you an idea of how to determine which risk category you should be using. In this case, we'll use a risk category 4. And then we have the basic wind speeds that we need to use. This is where the local wind speed associated to that building is. Now, there's a couple of links here that gives us a way to do tools to find out what the elevation is. These are both free, so the link doesn't cause a problem with anybody. You tap in your location, and then this is the ASCE7 hazard tool. Then you put in your risk category and put in wind, and then you can hit view. It takes a second. Get a full report if you want. But if you want to look, it says 125 miles an hour right here, and it also says 147 feet for elevation factors. So that would be basically how that would be used. I'm just going to go back to the calculator now. The other tool is the ATC hazard by location. This one again is you type in your location. And again, it gives you the 479 feet elevation and gives you all these different wind speeds all the way down to the 705 version if you're interested. The ones we want to focus on are going to be the risk categories. These additional ones here for MRI are used by structural engineers for different things other than roofing. So we want to basically focus on these types of winds. And again, it's 125. So that's what we would put into the calculator itself. So we come to the calculator, come down to 125, and then we have it good. The other is I'm going to skip the safety factor for a second and talk about the enclosed, partially enclosed, or open buildings. This is how many openings are associated in the building. So if it's 10% greater wall space has a opening on one side, that would be a partially enclosed. And the factors do change accordingly associated with that. Most of the buildings we deal with are enclosed, so we'll keep it that way. The safety factor is set at 1 because per the building code and per ASCE7, a cladding, which roofing is defined as, is not necessary to have a safety factor because of the liability and issues that we see out in the industry. A lot of people want to have a safety factor. The most common one is a 2. I've had people do Canada, which is 1.5, and I've had people do excessive amounts. So that number isn't decided by us as manufacturer or salesman. This is decided by the design professional. So if the design professional says he wants a safety factor, he needs to give it to us. If he gives none, I would not put any in. And then continue, and there we have our results. It basically gives you all the information that you're looking for that you plugged in, and then along with all the pressures that we need to meet or exceed. Now at the bottom, we do have what's referred to as no system, adhered system, and mechanically fastened system. No system is basically the document is printed without any reference to a system being used. This is what it would look like. at the end where you have all your information enclosed, category 4, and then the results based upon the calculations, the coefficients, the basic velocity pressure, which is up here through all that information, coefficients, and then these are the final results. This next box is basically applying a safety factor. Since we did a safety factor 1, the results are the same. And so we have no system referenced at the bottom, but this is probably what I would recommend as being the most common document that you should offer to a customer. It gives them the pressures, and then we can fill in the blank associated to the system that may be necessary if they haven't chosen one. At this point, we can actually hit previous and go back, and we can actually look at the other options, which is an adhered system. And if you hit continue again, you then have some options to put a system in, but we need to know the actual system application, meaning have the actual tested assembly that we list within our code books. I give you an example here that we've tested with 2-inch polyiso with 8 fasteners per 4x8 for an adhered system into a steel deck or concrete deck, and we get 90 pounds per square foot. So that's a default in this case, but you can raise it up to different levels. We do have a 150 with 20 fasteners. So that would be another application that we could use. But we're going to go back to the default of 90 and 8 in this case, showing you the example, because bottom line is when this is printed at the bottom, we have the rated system listed at 90 pounds per square foot. And then we show that all 4 zones in this case, because ASCE16 has 4 zones, we now have all 8 in all 4 zones. So that gives you an idea how it would work if the pressures were greater, and we can adjust that. We go back to our chart here. We can add a safety factor, say 2. We hit continue, and now we have 104.59 pounds per square foot. So if we hit 90 again, we're going to be short of that. But the calculator will calculate and extrapolate the number of fasteners and plates that would be necessary to compensate for those additional pressures. This is following the ANSI SPRY WD1 extrapolation method, or you could look at the RAS 117 document, which does the same thing. So there are 2 published documents that are out there that support this. Again, this is not following Factory Mutual and their enhancements. If the building was insured by FM, you would have to follow their guidance. The other option and last one is the mechanically fastened method. In this case, we have 10-foot wide, 6-foot sheets. Everything 6-inch on center is 90 pounds per square foot. We hit continue. We have all those same pressures again. I've included that safety factor, which again is not necessary. But then it shows here at the bottom that zone 1 and zone 1 prime would be 10 foot at 6 inches on center. Zone 2 would be 1 perimeter sheet, and that would be at 6 inches on center. And zone 3 would be 1 perimeter sheet for 6 inches on center. So that gives you an idea of being able to compensate and make sure that you're meeting the correct number of pressures and document necessary for the perimeter sheets for code. Keep in mind that there may be additional enhancements that might be required depending upon what the warranty being requested for. If it's just standard 55, this is not going to be an issue. But if it was 120 mile per hour warranty, there could be significant enhancements over and beyond this. So this does not work for warranties, but this does work for verifying the building code. So you can export this document as a PDF to be able to send it to your customer, and then they would have that documentation to send it on to their customer. That ends the educational portion. If you have any questions about the calculator or how to use it, please contact me and I will assist with you. Thank you very much.